Hello Year 11, this is our lesson on proofs involving similarity. Okay, so first example. Give you a moment to read that. Okay, now definitely in this kind of situation we need to have a diagram. So we start with our triangle, our vertices are called A, B and C. Now we need to know what altitudes are. Altitudes are perpendicular to the side that they join. So they go from a vertex to the opposite side, they join it at 90 degrees. So here is my altitude AE, and I know that I have a right angle, and then here is my altitude BF, and I also know that this is a right angle. Now, I can say that angle CEA is equal to CFB. I labelled them to help me notice that, but we know that they're both 90 degrees. I can also say that angle ACE and BCF are equal to each other. It's the same angle. From that, I can say that triangle CAE is similar to triangle CBF using the AAA rule, because I know that if two angles in a triangle are equal, then the third angle must be equal as well. From that, I can say that AE, remember that I want to list my vertices in the correct order. So C corresponds to C on these. A, the vertex that isn't a right angle, corresponds to B, the vertex that isn't a right angle. And F corresponds to E. Because I've listed those in order, which you do have to do, but then that also makes it much easier in showing these relationships here. So AE divided by BF, so the second two letters, is equal to AC divided by BC. What would be even better, which I haven't done, if you just redraw the triangles in the same orientation, then it's really easy to see that this side corresponds to this side. So I can do AE divided by BF, and this side corresponds to this side, so AC divided by BC. And that's what I was asked to prove. Okay, second example. I'll give you a moment to read it. Okay, now there is loads going on in here, so we're going to start with our diagram. Here's a trapezium. This looks like an isosceles trapezium. I don't know that. My diagonals, AC, BD, they meet at O. I label that. A line through O parallel to the base CD. So through O, parallel to CD, meets the line BC. At X, all of these are parallel, because the definition of a trapezium is it's got one pair of parallel sides. And this is what I'm aiming for. Now, at the moment, I don't know how that's going to happen, so I'm just going to get started on noticing some similar triangles. Triangle ABC is similar to triangle OXC. How do I know that? So here, this angle and this angle, they are corresponding angles on parallel lines. Similarly, with this angle and this angle, corresponding angles and parallel lines. It's supposed to be proper, I should have 2 lines there because they're not equal to the other ones. And then C is common. So they are similar using A. I'm going to get rid of that because otherwise it's going to confuse everything. I can also say that DCB is similar to triangle OXB for the same reasons. I've got corresponding angles and parallel lines here, corresponding angles and parallel lines here, and B is common to both triangles. Okay, so I can say that BX over BC equals OX over DC. That's using this pair of similar triangles. I can also say that XC over BC equals OX over AB. I'm going to label those 2 equations. Now I need to use a little bit of magic here. There's some things that I want to be keeping. If we go back to the question, these are the sides that I want to keep. I've got some sides in here that I don't want. I don't want BC, but there is a BC in both equations. I don't want OX. There is an OX in both equations. So what I can say is equation 2 divided by equation 1 gives me this. I'll leave you to work out quite how I've done that simplification. If you're still confused, then I can go through it with you later. So that gives me this, and then I can just cross multiply to give me bx times dc equals ab times xc. What you could do, because there are lots of different triangles we can be looking at in here, starting from the question, these multiplication situations, we don't normally use that, so you can say, right, so I know that I can write these fractions that are equal to each other, and then you can try to kind of partly work backwards and partly work forwards, but your proof should flow clearly in one direction. Okay then, so that's all of the examples. These are your questions that you need to do. Here are the worked solutions. And let me know on the discussion if you have any questions. Thank you very much.